Alright, so this video is a brief introduction to permutations and combinations. And so if we look at what I have written on the screen, what I've got is 6 different permutations. So just in my own words, definition of a permutation is just an ordering of objects. Usually we have orderings of letters or numbers, maybe both. But I've taken the letters A, B, C and just ordered them differently. So we can see these are different orderings. Right? I've got 6 of them. Those are examples of permutations, right? Because the ordering, when I change the order, I get a different permutation. However, all of these are an example of the same combination. Right, so I really only have one combination of numbers. I have 6 different permutations, or I'm sorry, one combination of the letters, A, B, C, but 6 different permutations. So the main distinction between a permutation and a combination is whether or not the order makes a difference. There's going to be more permutations than there are combinations, because if you put the objects in a different order, you get a different permutation, whereas with a combination that doesn't matter. A familiar example, I think, to most people is when you play the lottery. So if you play, for example, the Powerball, you choose, I think you choose 5 numbers or something like that. Maybe these are your numbers, 30, 41, 45, and then you choose this Powerball number, right? And when you go and you choose your lottery numbers, that's a combination, because if you chose these in a different order, you still have the same winning combination. So you might say these were the winning numbers. They don't necessarily have to be in that order. You could choose them out of order, but those are still the winning numbers. So this list and this list are 2 different permutations, but ultimately they're the same combination. If one person chose the numbers in this order and another person chose the numbers in this order, they still have the same winning numbers, right? They have the same winning combination, although they are 2 different permutations. Okay, and so we've got 2 formulas that we're going to use. Here's a formula for permutations, and here's a formula for combinations. The way I like to read these is, the first one is the number of permutations of n objects taken r at a time. And same thing for the second formula. It's combinations of n objects taken r at a time. And so we'll work through some examples where we'll use these formulas. And this first example says find the number of 2 permutations of the set of letters A, B, C. So in other words, we've got a set of 3 objects. We're going to take 2 at a time. So how many different permutations are there if we took 2 objects out of that set? Right? And so we're going to take the permutations of 3 objects taken 2 at a time, and I'm going to go back and look at my formula. And so n here is 3, so I'm going to start with 3, and then multiply by 3 subtract 1, which is 2, until you get down to whatever this ends up being. Now in my case, n is 3, r is 2, so 3 minus 2 is 1 plus 1. So in this case, this is where I would stop. Right? This is where I would stop. Right? I multiply, I subtract 1, subtract 2, until I get down to whatever number this is. And in this case, I stop when I get to 2. right? So 3 times 2 is 6, and so if there's only 6 of them, we can probably list these different orderings. If I pick 2 letters, how many different orderings are there? There's A, B. Of course, it would be different if I had B, A. There's A, C, or C, A. Or there's B, C, or C, B. Those are the 6 different permutations of 2 objects out of that set of 3. Okay, here's another example where this is kind of going back to, we were counting how many people can be on a committee. And this is going to be an example of a permutation because it says, in how many ways can we select a chairperson, vice chairperson, secretary, and treasurer from 10 distinct people? Right, so order makes a difference here. Right, if we have a committee where the chairperson and vice chairperson are switched, right, that's going to be a different committee. So order matters. So we know we're using a permutation. We've got 10 objects or 10 people, and we're going to choose a chairperson, vice chairperson, secretary, and treasurer. Right now, right, so we take 10 and we subtract 1 and multiply until we get down to n minus r plus 1. In this case, that's 10 minus 4 plus 1. 10 minus 4 is 6, plus 1 is 5, so that means I'm going to take 10, subtract 1, multiply, subtract 2, multiply, until I get down to 5, and then I stop. And if I multiply all those together, lots of different committees that we can form. If we have 10 people and we're choosing 4 officers. Right, so that's a good example of a permutation. Of course, we can do the same type of thing with combinations. So find the number of 2 combinations. So same idea as the first example, except now we're doing combinations of 3 possible objects, taken 2 at a time. And I'm going to plug into this formula where n is 3 and r is 2. And so if we have 3 factorial, just a quick reminder that that's 3 times 2 times 1. Right. 4 factorial is 4 times 3 times 2 times 1. Alright, so if I write this out, I've got 3 times 2 times 1 on the numerator. This guy is just 1 factorial, which is just 1. And 2 factorial is 2 times 1. So one thing you can do when you're computing a combination is a lot of times you can cancel things out. Now the numbers are small enough here that it may not make a difference, but this 2 times 1 and this 2 times 1 cancel out, and we'd be left with just 3 over 1, which is 3. There's fewer 2 combinations than there were 2 permutations, right? The 2 combinations, it's just any combination of 2 letters from this set of 3. So we can take AB. That's not any different from choosing BA. Those aren't separate combinations, right? We don't have to worry about that. We can take AC. Not any different from choosing CA, because these are the same combination of letters. Order does not make a difference. Or we can take BC, not any different from choosing CB. That doesn't matter. Order doesn't make any difference. So these are the 2 combinations out of that set of 3 letters. And a little bit more applied example of a combination. How many ways can we select a committee of 3 from a group of 10 distinct people? So notice the difference between this one and the second example. Second example specified that we had a specific order of officers in our committee. In this fourth example, definitely no order specified. We just need a committee of 3 people. Doesn't appear that there's going to be any chair, vice chair, treasurer, or anything. So we're just simply choosing some combination of 3 people out of 10. So we have a combination. We're going to take 10 objects and choose 3 from them. So plugging into that formula, this is N, this is R, so I've got 10 factorial over 10 minus 3 factorial times 3 factorial. Let's make sure I plug those in right. And that looks okay. So if I, sorry, was just double checking to make sure. Just double checking to make sure I had that plugged in correctly. So if I was going to write this out, 10 times 9 times 7 all the way down times 2 times 1. Now this guy right here is going to be 7 factorial. That's 7 times 6 times 5 all the way down times 2 times 1, and then this is 3 times 2 times 1, 3 factorial. Now to make life a little bit simpler here, I've got 7 times 6 times 5 times 4 times 3 times 2 times 1, both in the numerator and denominator. Those can cancel out. And actually, I made a little bit of a mistake there because I left out my 8. It should be 10 times 9 times 8. Right, so what's left is just 10 times 9 times 8 in the numerator, and then just 3 times 2 times 1 in the denominator, and this is what I had written down. I didn't write everything out, which is why I was double checking to make sure I had that copied down correctly. And so, you don't have to do this, but I think this is a simpler expression to work with. Maybe you could even do that in your head, or certainly punch into the calculator if you need to, and that comes out to be 120. Right, so we're sticking with the most basic, simple ideas of permutations and combinations. We just want to introduce you to the two ideas and get you to a point where you can tell the difference between a permutation and a combination. So hopefully that helps.